Okay, on to our last page of questions. So the top one is about RC filters. We have a 1 μF capacitor and a resistor whose markings are hard to read. We determined that the filter has a cutoff frequency of 1845 hertz, and we need to find out what the value of the resistor is. So we're going to use the equation that we should know or have on our cheat sheet, which is FCO is equal to the cutoff frequency is equal to 1 over 2 pi RC. And so we're going to apply the values that we know to this. And so we have, we can sort of reconfigure this equation. We're solving for R. So we have R equals 1 over 2 pi CFCO, cutoff frequency, and that's equal to 1 over 2 pi, 1 times 10 to the negative 6. That's coming from our 1 μF. And then 1845 hertz is coming from our cutoff frequency, and that gives us a value of 86.3 ohms. So again, just plug and chug in this case, make sure you read the problem, identify the components that you need, and then reconfigure the equation correctly and check that your value kind of makes some sense, right? 86.3 ohms is a reasonable value for resistance. And then part B, a sine wave with frequency 1845 hertz and a power of 4 watts is input to the RC filter. What is the power of the output signal? So this is something you should know from the notes. And again, it's a good cheat sheet thing to write down if you don't remember this, which is that the cutoff frequency, because we are not using a sort of ideal filter, right? This is a real RC filter. The cutoff frequency is half power, right? We have this sort of chart where we lose power over time, and this FCO is where we're at negative 3 decibels, so half of the power that we would normally have, which means that we should have 2 watts of the output signal. So that's it for that one. Let's move on to the bottom of the page, which is an AM signal plot in the time domain, and we're supposed to fill in the frequency domain plot with the missing labels as shown on the right and determine the missing values. So here we need to use the equations. This is you can basically just, again, plug and chug as long as you have these on your equation sheet. So we've got Vmax is 14 volts. That's taken from the diagram up here. We've got Vmin equals 7 volts, again, taken from the diagram. And so we're going to calculate our Vc equals Vmax plus Vmin over 2. And Vm equals Vmax minus Vmin over 2. So Vc is 21 divided by 2 is 10.5 volts. Vm is 7 divided by 2, which is 3.5 volts. And so that's our values for Vm and Vc. It's not quite what goes into our chart yet. We know that middle spike this is Fc. This is Fc plus Fm. This is Fc minus Fm, right? The lower sideband and the upper sideband, and then the carrier frequency. So A is going to be Vc, and then these, we can either just know this, or if you really want to derive it on the exam, you can, is Vm over 2. And so we've got our value for A already, that's 10.5. We've got to calculate a little bit more to get 3.5 to Vm divided by 2, and that's going to be just 3.5 divided by 2, so 1.75 volts for our values here. Now we need our values for the frequencies that we can then turn into the values that we want to have for C and D. So we need to calculate Fc, and we need to calculate Fm. We don't actually have any great way to be able to do that directly, right? We don't have those already from the chart. The way we need to calculate it is based on doing a period, and then calculating from there. So this is going to be TM, and then our peak to peak is going to be TC, but we actually are already given that value, right? So if we had to calculate it, we would measure from peak to peak here, peak to peak, and just how far apart those are. Calculate. In this case, we're given FC, so we know that that is 10 kHz. It's nice for us. So FM is going to be 1 over TM, is 1 over 2 milliseconds, because we've got 12 minus 10. And so that's going to be, turns out that's 500 hertz, 4.5 kHz. So now for our lower sideband FC minus FM, we take 10 kilohertz minus 0.5 kilohertz, and that gives us 9.5 kilohertz. This FC minus FM. And then FC plus FM, 10.5 kilohertz. Another reasonable question to follow up with would be like, what is the bandwidth of this signal, which would be the upper sideband minus the lower sideband, so 10.5 minus 9.5, 1 kilohertz, based on the 2 times 500 megahertz as well. That's it for the exam. Good luck.